So the re module. I'm going to go over email addresses, telephone numbers, and then I'm going to go into a portion of one more complex pattern that will allow you to extract timestamps, levels, emails, and IP addresses from a entry log type string structure. So first of all, the re module is a way to search strings for certain patterns, whether you want to return them or alter them in place. The core of that is creating these strings or regular expressions that define the pattern you wish to search for. I would recommend using raw strings to make these patterns simply because you can avoid extra escape characters. So this is a list of the unique keywords, so to speak, that you're using to write your strings that become the patterns you're going to search for. Now this isn't an exhaustive list. If you wish to find more information, go to the PyDocs for the re module. But I warn you, it's a bit dense, very verbose, and not necessarily rich with examples. So let's dive into the first pattern, which is going to be searching for this John Doe. Please make a note that the upper right here is where I have the output and what is found. So the patterns. First of all, the syntax. So you're making a variable and you're making it equal this pattern simply for multiple use. You could write it here if you desired, but it would look a bit messy. And so you create a variable with your pattern, and then you create a variable that's going to house your return value. And then if you wish to find the first instance of your pattern, if found, you can use the search method. And going into the string pattern, which is the only thing I'm going to go through for the rest of this, is the different string patterns, because that's the most difficult part to understand. First of all, you can block patterns and enclose them in square brackets so that you may then combine different patterns and different literal strings or literal characters together in a way that will allow you to search for complex patterns. So in this way, the first pattern that we're trying to search for is an alphanumeric set of characters that also includes a period, a percentage sign, underscore, plus sign, and a hyphen. So this \w represents all characters, lowercase and uppercase, as well as the digits. So it's the same as this line, just a shortened version. And then you use the plus symbol to combine different elements of your string that you wish to search for. And so it's taking any alphanumerical quantity of characters that can include these special characters here. And then it has to have an @ symbol, and then any alphanumerical characters of any length, and then also it can include a period or a hyphen, and then it has to include a period. So just note that it had to be escaped here because a period is also used for matching any character. So just note that you're going to have to use escape characters for any time you want to use one of these literally, or search for literally. And then you have the last and closing brackets just outlining it has to be alphabetical, and then these curly braces here right after this enclosed alphanumerical pattern means that you want to have a minimum of 2 characters or more. And so that's what the 2 comma represents. And when you run that code, you end up getting, again, to just explain it in those terms of those patterns, this first element represents all of this, right? Because it's everything before the @ symbol. Because you include periods and alphanumeric letters, this passes the first test for the pattern. And then it has the @ symbol. And then again here you have alphanumerical until you get to a period, which was defined here. And then again you have a minimum of 2 or more, as you can have co or what have you, .com, .co, .ninja. And so this allows you to capture just the first element by using search. You can use the findall method to then capture all of the emails and have it returned as a list. Now I'm not going to go over the next example, which is just a literal way of finding this formula, but I'm going to go over the one afterwards, which is going to allow us to search for phone numbers. So here, just make note that you can write phone numbers in many different ways. Here I'm just using the phone number syntax or nomenclature for the US, not European, which means that you can separate your numbers by periods. You don't have to put anything or any separation. You can separate the first 3 digits with parentheses and then separate the last 3 and 4 with a hyphen. You can do all hyphens. So how do you write something to capture all of those possibilities? Well, what you do is you can escape a parentheses, the opening parentheses, and then you can use a question mark to say 0 or 1 of these elements are allowed. And then here you have the \d, and that represents just digits between 0 and 9, and then exactly 3 of those allowed. And then you're escaping the enclosing parentheses, and then you're using that question mark again to say 0 or 1, which means it's either going to capture parentheses surrounding 3 digits or just 3 digits. And then back to back, it's defining here. Just note that there's no separation, there's no plus symbol. So you have enclosing brackets outlining that you can have a hyphen, a period, or white space, and that's what this \s is. It just means white space. And you can have 0 or 1 of any of these. So not all of them, one of them. So it can be, so what's going to separate the first 3 digits is either going to be a hyphen, a period, or white space, or nothing. And then again, right afterwards, you're saying the next 3 digits separated by any one of these or none, and then you have the last 4 digits. And the results of that here, it found the individual one for the first example, and when it did find all, it returned this list of all of those numbers in there, successfully capturing all of the different numbers. And now to go into a more complex example, I'm only going to go partly through it, mainly because I want to get to the fact that you can outline or define, using these parentheses, certain specific elements of your patterns that can then be referred to as this timestamp. And this is a way for you to capture those different elements. In that, just note the syntax here. You have timestamp, level, email, and IP address, and patterns for each one of those. And then when you wish to create your match and then group them, you can group them by that term, which can be very useful because then you can search through all of those different entries and then store the information in different areas much easier because you can refer to it directly. So again, so that syntax would be enclosing the entire element in parentheses, then using the question mark capital P, and then greater than less than symbol enclosing the variable name that you wish to use, the name for the group. And then here it's just more of the same that we've been going over. You have digits of a certain fixed quantity that can either be separated by these 2 elements or nothing, and so on and so forth. But the one thing of note here would be this OR symbol. So while it's doing its search, it's going to either find an example of this or this, and I think that's very powerful. Meaning, if we go over the actual log entries, you have them written differently. You have them written with a T in between them, or you have them written using full notation, or 3-character notation for the month. And then you also have times or dates separated by both hyphens or by slashes. So again, you can separate out your elements that you can then refer to using the match.group and then your variable name. You can also have these sections separated out by using OR to find one or the other types of patterns. And hopefully this got you a bit further into understanding regular expressions and the re module. This is Grover, Blue Collar Codes. Thanks for joining.